In this lesson, we are going to learn how to perform a hypothesis test for a population proportion. Here's our first example. A presidential candidate's aide estimates that among all college students, the proportion P who intend to vote in the upcoming election is at most 65%. If 186 out of a random sample of 275 college students expressed an intent to vote, can the aide's estimate be rejected at the 0.01 level of significance? Perform a one-tailed test, then fill in the table below. Carry your intermediate computations to at least 3 decimal places and round your answers as specified in the table. First of all, notice that you need to distinguish this type of question from the previously learned types of questions. This time we are not talking about performing hypothesis test on the mean of the population. Nowhere mean is mentioned. However, we clearly have proportions. Why? Because we're told that 186 out of 275 college students, that's a ratio, that's a quantity we can convert into percents or proportion of all college students. And again, one more indication, the actual word proportion P is listed. So there's no doubt this is a test regarding proportions. Let's find out what we are given. We are told that X is equal to 186 and N sample size is 275. So P hat sample proportion is 186 out of 275. Alpha is 0.01. Whenever you need to perform hypothesis test on population proportion, you need to make sure that the requirements are met, and the requirements are randomness of the sample, and also one of them is the product n p sub 0 and n times 1 minus p sub 0 is at least 10. So I'm quickly checking these facts, and they are, and I'm ready to move on with this process of hypothesis testing. Please notice that the verbiage of this problem is quite tricky. In previous examples that we've done when we worked with mu, most of the time you were asked whether the claim can be supported, or do we have enough evidence to support this claim, something of this nature. This time you are asked, can the aide's estimate be rejected? This is a game changer. This one word, rejected, is what makes the claim of this candidate's aide to be the null hypothesis statement. Why? According to the definition of what null and alternative hypotheses are, we know that null hypothesis is assumed to be true until proven otherwise. Alternative hypothesis is what we will have to take as true statement whenever null hypothesis is rejected. However, I cannot reject the alternative hypothesis because I don't even know if it's true yet. So whenever you're talking about some claim that we would like to possibly reject, this word always tells me that this claim has to be the null hypothesis claim. So for P to be at most 65% means P is up to 65% or less than or equal to 0.65. The alternative has to be the opposite statement. P is greater than 0.65. Whenever you work with proportions, the test statistic is always Z, and we're going to use the one proportion Z test on TI-84 to get the Z value, the test statistic, and P value, the area with respect to this test statistic. So when I input the information I have into this test on TI-84, I got these numbers. Z is 0.917 and P value is 0.180. What does it mean? It means that I have a right tail test, so I am taking 1% of area in the right tail, and I highlighted with blue. This is my rejection region. Well, it happens so that Z value has more area than the 1%, much more actually, 18% of it. So this test statistic, which is 0.917 right here, it is well in the acceptance region, and we will not reject the null hypothesis. I'm going to say do not reject H sub 0. So we're going to say, no, the 8th estimate cannot be rejected at the alpha equals to 0.1 level of significance. We still hold it to be true based on this evidence. Now, let's see how we get the z-value, test statistic, and the p-value using TI-84. I copied the information to have it handy when I enter information into my TI-84 calculator. And here we go. I go to test, which is under statistics menu, and I choose option 5, 1 proportion z-test. It will ask you for the proportion to which you're comparing, which is 65% in our case. X is 186, N is 275, and we work with the right tail test, as you remember on our picture, and we press calculate to find the information. Please notice z-value, as I said, would be 0.917, and p-value, when rounded to 3 decimal places, would end up being 0.180. And again, the conclusion, we already talked about it. This is how the TI-84 can help you perform the test on population proportions. We will look at another example, this time the two-tailed test. A decade-old study found the proportion P of high school seniors who believed that getting rich was an important personal goal was 80%. A researcher decides to test whether or not that percentage still stands. He finds that among 210 high school seniors in his random sample, 172 believe that getting rich is an important goal. Can he conclude at the 0.1 level of significance that the proportion has indeed changed? Perform a two-tailed test, then fill in the table below. Carry your intermediate computations to at least 3 decimal places and round your answers as specified in the table. Let's take a look at the given information. I know that P hat sample proportion is a 172 out of 210 seniors said that getting rich is an important goal for them, and that gives me 0.819 rounded to 3 decimal places. Alpha is 0.1. I quickly check assumptions which they are met, so I can continue with performing this test. The hypothesis statements. Please notice I am just wondering if the proportion has changed or didn't change. Therefore, the alternative hypothesis, H sub 1, will say that proportion is different now. It's not same as it used to be at 80%. And the null hypothesis will claim that it is still the same. It is equal to 0.80. Again, test statistic is Z. Let's find it using the TI-84. I go back to option 5 on my test lists, and I get z-value of 0.690 and p-value of 0.490. Well, this particular question in ALEKS is asking to use not the p-value approach, but critical value approach to a decision, and therefore I need to compute the critical value first. In this case, values, because we have a two-tailed test. So I am finding critical values plus or minus z sub 0.05. I want this z-value that has 5% of area to the right of it, and I want its opposite on the other side of 0. There must be symmetric with respect to 0. I use the inverse norm because I work with z-scores, and I find that 0.05, this quantity right here, has 5% on the left, with 0 and 1 as my mu and sigma. The two z-values come out to be plus and minus 1.645. So these are the two locations right here and right here that separate the two critical regions. With alpha of 10%, it means 5% is on the left, 5% is on the right. Now it's a decision time. With z-value, the test statistic of 0.690, I need to find its location on this z-axis, and it is pretty close to 0 to the center, and definitely within the acceptance region and not in the rejection regions, not in the tails. Therefore, I'm going to conclude that we will not reject the null hypothesis. No, the proportion of high school seniors who believe that getting rich is an important goal has not changed at the alpha equals to 0.1 level of significance. It is still at 80%.